Okay, so this is the mock higher tier question 1. A skydiver of mass 80 kilograms weighs 800 newtons. Use the equation acceleration equals resultant force divided by mass to calculate the acceleration of a skydiver of mass 80 kilograms when the air resistance force is 200 newtons. So we can see that his weight is bringing him downwards with a force of 800 newtons, and air resistance is preventing him from falling with a force of 200 newtons. So the resultant force that he's experiencing as he falls is the 800 newtons take away the 200 newtons. Of course, 800 take away 200 is 600 newtons. So that's the resultant force. And then if we use that value in this equation, then we can work out that 600 newtons divided by his mass, and his mass is quoted as 80 kilograms, gives us an acceleration of 7.5 meters per second Okay, and if we move on to the next part of this question, which is a QER question, QWC as it used to be. So when a skydiver opens a parachute, he decelerates until he reaches a small terminal speed of about 3 meters per second for landing. Discuss the above statement, include in your answer the following points: an explanation in terms of forces why a skydiver decelerates when the parachute is opened, and an explanation of how a small terminal speed is achieved for landing. Okay, now as this is a QER question or a QWC question, rather than me write out a long extended answer, I shall refer to the official mark scheme. Okay, so if we have a look at this, it tells us this is the indicative content, so this is the sort of thing they're looking for, and then it then bands that into these 3 different bands as far as quality is concerned. So when the parachute is opened, a big air resistance force is produced that acts upwards. This is bigger than the person's weight, which is downwards. The resultant force is upwards, and so the person decelerates. Remember, that doesn't mean the person flies upwards, it simply decelerates. As the speed decreases, the air resistance or resultant force decreases, and the deceleration decreases. Eventually, the speed becomes so low that the air resistance and the weight become equal, and the person falls at a low, constant speed. So that's the sort of text that they would be looking for. Now, here we have the different bandings. So for 5 to 6 marks, that's the higher marks that you're aiming for if you're looking for the top grades. It says the candidate constructs an articulate integrated account correctly linking relevant points, such as those in the indicative content, which shows sequential reasoning. So in other words, your writing is clear, it links things together properly, and it makes sense. And it's written in a sequential manner, which means in an appropriate order. The answer fully addresses the question with no irrelevant inclusions or significant omissions. The candidate uses appropriate scientific terminology and accurate spelling, punctuation, and grammar. Okay, so your answer is relevant. Everything you place in there means something, and you've not missed anything important out. And the way in which you've written it uses the right wording and would make your English teachers proud. For 3 to 4 marks, the candidate constructs an account correctly, linking some relevant points, such as those in the indicative content, showing some reasoning. Okay, so it's a lower quality piece of writing, and your answer addresses the question with some omissions, so you miss some important bits out, and you use mainly appropriate scientific terminology. Okay, so you might use a few common terms instead of the correct science terms, and your spelling, punctuation, and grammar are good. And then obviously at 1 to 2 marks, you make some relevant points, and you show limited reasoning, so you don't really explain the answer properly. You leave lots out, and you have inaccuracies in your terminology, spelling, punctuation, and grammar. And then for no marks, if you've not made an attempt at all, or it's very, very poor, you would get no marks there. Okay, so that's the second part of that question. So if we now move on back to the final bit, okay, which is this one here. So the correct size parachute is important to give a small terminal speed. A heavy person needs to have a different size parachute from a lighter person. Explain why a heavier person needs a different area parachute from a lighter person to achieve the same small landing speed. Okay, so we're looking here for the resultant force to be the same no matter the size of the person. Okay, so consequently, a larger person has a larger weight, okay, and therefore it will be pulled down more effectively by that, so they will need a greater air resistance, and to get that they need a bigger parachute. Okay, so you need a bigger parachute, and that bigger parachute gives you a greater surface area. That's shoot there, which is greater surface area, and that greater surface area produces a larger wind resistance or air resistance, larger air resistance, which means a larger force. Okay, so the air resistance force, and therefore those two things combined would reduce the resultant force. Okay, so larger people need larger parachutes, basically. Okay, that's question number 1.